Hi, good morning to everyone. In this session, we have to discuss about some corrosion control methods. These are the methods to be discussed. And the first one is a sacrificial anodic protection method. In this method, the metallic structure which has to be protected is kept as a cathode, and this cathode is connected to more anodic metal through the wire. So here the metal which that more anodic metal can be act as a sacrificial anode. That means these more anodic metal undergoes corrosion rapidly and releases electrons. These electrons are consumed at the cathode by the corrosive agents. So overall, that cathodic metal is protected now. So again, I have to say the metal which has to be protected is placed as a cathode only. At anode position, we have to take more anodic metal. So both of these things, anode and cathode, are connected through the wire. So these more anodic metal acts as a sacrificial anode because it undergoes corrosion rapidly instead of that another protected metal. So these electrons are received from the anode to cathode, and these electrons are consumed by the corrosive agents. This is the important thing. After long duration, if all the sacrificial anodic material has been destructed, so after destruction of this, we have to replace these sacrificial anode with another freshly more anodic material. So this type of corrosion protection metal can be useful in case of pipelines, underground objects, marine structures, etc. So here we are not advantage is we are not using any external power, and maintenance and installation cost is very less. Limitations: it is not suitable for large areas, and that uncoated parts cannot be protected. So next one is impressed current protection. In this method, that protected structure and anodic metal both is connected to the power supply. Here DC current is given to direction opposite to that of the corrosion current. That means corrosion current has been nullified by supplying the electrical power. That is the main concept behind this corrosion protective method. So here and these methods are useful in case of buried oil, water pipe, condensers, etc. So these protection techniques are useful for large stretches for long-term use. So now advantages: larger objects can be protected, and uncoated parts also can be protected. Limitation is installation and maintenance is very high and high cost, and we cannot do that. So next one is metal coatings or anodic coatings. So these coatings are produced from coating metal. That means that metal which has to be protected is coated with another metal which are more anodic to the base metal. That is the important thing. So here again I have to say that metal which are more anodic to base metal are used to form a coat on the metal to be protected. So for example, we have to say zinc, aluminum and cadmium coatings on steel. So these zinc, aluminum and cadmium are having a more less electrode potentials, and they undergoes corrosion rapidly instead of that base metal. So if any pores or breakups are happened on the surface of the metal, then galvanic cell is formed between that anodic coating and base metal. So this is the very important thing here. So here I gave one example. So zinc dissolves anodically, so iron is protected because here iron is coated with zinc metal. So zinc metal is having more corrosion ability. So zinc dissolves completely in anodically in the electrolyte, and iron which is protected is kept as a base metal, and it has been protected from the corrosion. So next one is cathodic coating. Here coatings are obtained by coating. Here this type of coatings are obtained by using noble metals. Noble metals or inert metals are coated on the surface of the metal which has to be protected. For example, if a tin metal is coated on this iron metal, then tin is having more resistance against the corrosion, so it won't be undergo corrosion. Thereby, the base metal can be protected very easily from the corrosive agents. If any discontinuous or pores or breaks happened, then corrosion will be started. So difference for anodic coating. In this anodic coating, the protects the underlying base metal significantly, but cathodic it protects underlying base metal due to its noble character. That means here that sacrificial character of anodic coating protects that base metal. Here the noble character, that means higher resistance against the corrosion, that thing protects that base metal. Next, electrode potential of coating metal is lesser than that of the base metal. Here that coating anodic coating metal is having lesser electrode potential than that of the base metal. Here electrode potential is very high because it is having more resistance against the corrosion. So that metallic coating is having a higher electrode potential than that of the base metal. Next, if any breaks or discontinuous happens, then coating will be destroyed and corrosion will become more. And here, if any discontinuous happened, then here also that corrosion will become more. Next example is a zinc on ion, and this one is a tin on the ion. This is the important